Hi to all. Today I am going to explain the total internal reflection. What is total internal reflection? In the name only there, the totally lateral reflected back, that is called as total internal reflection. And when it will occurs and what is the condition for the total internal reflection and what is the definition of total internal reflection and what are the uses of the total internal reflection, applications of total internal reflections, that all things today we are going to discuss. And firstly, what is the total internal reflection and when it will occur? For the purpose, let us see here. And when let some light ray, one light ray, it is trying to move from denser medium to rarer medium. For example, it is the boundary which separates the two mediums. For example, this is the boundary which separates the two mediums. Okay, let us consider this is the boundary which separates the two mediums. And above this rarer medium is there and below this denser medium is there. This is the layer which separates the two mediums. For example, one light ray is allowed to incident on this boundary and it is trying to move from denser medium to rarer medium. To know the angle of incidence, we have to draw the normal. Just let us draw the normal for on the boundary. And this is normal means it is a line. It should make 90 degree with the surface, right? Normal means it's a line, it makes 90 degree with the surface. This is the normal drawn to the surface which separates the two mediums. And let us take one light ray which is allowed to incident on the surface. Let us consider this is the light ray and it is incidenting and it is trying to move from denser medium to rarer medium. And here the angle of incidence, the light ray is incidenting at certain angle, right? The angle of incidence when light ray is trying to move from denser medium to rarer medium, it cannot go in a straight line, it will bends. You see here, this is the actual path of light ray. When there is no change in medium, light will travel in a straight line path, but due to the change in medium, when light ray moves from denser medium to rarer medium, it will bends away from the normal. That means this is the normal. From there, it will bends away. This is actual path. From actual path, it will bends away from the normal. Okay, and here we are increasing the angle of incidence, and it will bends and bends and bends. And at a particular angle that is called as critical angle, light ray moves along the surface. We know that one. This is if the angle of incidence is equal to critical angle, the refractor light ray will goes along the surface which separates the two mediums. We know that one, that is angle of refraction equal to 90 degree. Corresponding angle is called as angle of incidence is called as critical angle. Here we see that is angle of incidence. If it is greater than critical angle, what happens? Further it will bends. Further it will bends means the light ray will be reflected back into the same denser medium, and this phenomena is called as total internal reflection. In this there is no loss of light. Okay, and totally the light ray is reflected back into the same denser medium. And when it happens, what are the conditions for that? Conditions to get the total internal reflection, let us write. What happening it here? The first condition is that conditions for total internal reflection. What are the conditions? What happening in this in the figure that we have to write? The first condition is that light ray is trying to move from where to where? Right. Light ray moves from light ray tries to move from denser medium to rarer medium. Denser medium to rarer medium. And the second condition is that when light ray moves from denser medium to rarer medium, it will bend away from the normal. And the second condition is that angle of incidence should be greater than critical angle. Angle of incidence. Angle of incidence is greater than greater than critical angle, greater than critical angle. These are the two conditions to get the total internal reflection. That means if I greater than C, then TIR, total internal reflection, takes place. Okay. Now, if you want to define the total internal reflection, how we will define? Let us go for the definition of this one. Okay. And the definition is that just you have to combine the conditions, you will get the definition. Okay. It was very easy. Let us go for the definition of total internal reflection. Definition of total internal reflection. What is the definition? Okay. Now it was very simple. That is when light ray moves from denser medium to rarer medium. When light ray moves from denser medium to rarer medium. Denser medium to rarer medium. If angle of incidence, if angle of incidence is greater than critical angle, if angle of incidence greater than critical angle, then light ray reflects back, light ray reflects back into same denser medium, same denser medium. This phenomena is called as total internal reflection. This phenomenon is called as total internal reflection. Total internal reflection. This is the total internal reflection. Okay. What is total internal reflection? If the light ray, when it tries to move from denser to rarer medium, if angle of incidence is greater than critical angle as shown in the figure, the light ray will come back to the same denser medium and it will also obeys the laws of reflection, and this is called as total internal reflection. And now we are going to discuss the few important applications of total internal reflection. Okay, take the screenshot and note it.